Hello and welcome. Today, I want to talk to you about differential equations, in particular, the first order differential equations. So, uh, the first order differential equations. Now, you find that these first order differential equations, they do have a standard form, which is given by um, dy by x plus p of x, y, and this is equal to q of x, like that. So that is the standard form in which different first order differential equations come in. And the requirement for you in terms of mathematics to deal with first order differential equations is to find a solution to the differential equations. And to find a solution, you'll find that we already have a standard solution or a prescribed solution to this first order differential equation. And the solution is given by Ry is equal to the integral of r q of x um, dx, and of course plus c, the constant of integration, where r is what we call the integrating factor, factor, sometimes abbreviated as IF. And you find that this integrating factor R is actually given by e to the power of integral p of x dx, like that. And which p of x? The p of x that you find in our differential equation. And as you calculate this integrating factor, then the next thing that you will have to do is to go back into your solution and substitute the value of r, and all then you need to do is to integrate this portion, as I am going to show you in the following example. So let's look at a practical example to see how to actually solve a first order differential equation. Let's look at example number one. If I'm given, say, dy by dx plus xy is equal to x, like that. So the very first thing that I need to do here is to pick what is my p of x. In this case, that will be x, and what is my q of x? That will be equal to x. So you can see this differential equation is already written in the standard form. So you have your dy by x, your p of x, and your y and your q of x. So once you have established which one is your p of x, which one is your q of x, the very next thing would be to uh, calculate the integrating factor r, which is given by e to the power integral of p of x dx, like that, and that is equal to e to the power integral of x x, and that gives us e to the power half x squared, like that. So that is my r. So now that I've got my integrating factor, I go on into the solution and substitute that. So the solution will then be given by r, which is e to the power half x squared times y, being equal to the integral of r, which is e to the power half x squared um, times q of x, which we saw it is x, dx, and of course plus c, like that. So our focus now would be to integrate this part here, the integral of e to the power half x squared plus x with respect to x. And you can see that now when you integrate there, you're gonna have to know some integration techniques. For example, in this case here, I can see that this integral I have here, if we have a technique which says that if you integrate e to the power f of x times f prime of x dx, the solution to that should be e to the power f of x, like that. And of course, plus the constant of integration. So I can see here that my f of x is half x squared. So if I differentiate half x squared, I'm actually going to get x. So that means the integral part of this here would be equal to e to the power half x squared, and of course plus c. So ultimately, my solution to this differential equation would be given by this here. And this solution, we call it a general solution. And the reason why we call it a general solution is because in this particular question, we're not given some conditions to find a specific value of C. So hence this becomes a general solution because we don't have a specific value of C, or we don't have conditions for us to calculate the value of C. So that's how you solve a first order differential equation. I'll be coming in the next videos with more differential equations that we can solve. Please kindly subscribe to this channel and also click the like button and make some comments. Thank you.